All right, this is Coach Williams, and we are going to go over kind of a review for our practice EOC test. So this is kind of a, conglomerate, a complete review from 1 to 9, I guess you could say. Obviously, it's not a very thorough review. We just touch on some of the problems in these units and chapters. So we're going to go through this rather quickly because, again, most of this should be review. And hopefully we should be able to grasp this pretty quick without actually reteaching it. The first thing it asks us to do is write an equation in slope-intercept form of the line with the given characteristics. And slope-intercept form, you may remember, is just y equals mx plus b. Okay? Now, that's the form they want, but they don't always give us the information in the way we need to write this form. They may give us information for a different form, and then we got to, move it into this form or change into this form, and that's where algebra comes into play. What they give us on the first one is they give us a point, right? This is a point right here, and they give us a slope. And I will make mention of this. You're going to be given one of these reference sheets for formulas and so on and so forth for algebra. And so you'll see there's lots of formulas on here. You'll be given one of these for the practice STAR test and for the actual STAR test too. So, you'll have these at your disposal as needed. And what you're going to look for is what they give you. They give me a point and a slope. And so there is a linear equation that I can use here that's point-slope form, which is that y minus y1 equals m times x minus x1. The y1 and the x1 just being the values of the point that they give us, m being the slope. All right, and so they give us this form, so that's what we have to use, but we can change it into whatever form they ask us to change it into, in this case, slope-intercept form, which is y equals mx plus b. So, again, we're going to put it in this form. Y minus y1 equals m times x minus x1, where x1 and y1 are just the point values, or the values of the coordinates for x and y here. Okay? So that's my x1, that's my y1. All right, now, if I put those values in, I'm going to have y minus the y value, which is a 1, equals the slope of 2 times x minus a negative 3. And we all know by now, minus a negative just means we're going to become a plus, right? So I'm going to have y minus 1 equals, and I'm going to go ahead and distribute the 2 into the x and the 3. So I'll have 2x plus 6. At this point, I also know that I need to get this into this point or slope-intercept form. So I need it to look like this. So I need to get y by itself. And to get y by itself, I'm going to have to move the 1 across to the other side, which means I add 1 to both sides. All right, so final form here, y equals 2x plus 7. And that should do it. We have it in our slope-intercept form. Okay? The next one, they tell us that it goes through this point. So once again, they're giving us a point. And then they say it's perpendicular to this equation right here. And perpendicular, we always pull these things out. When I see perpendicular or parallel, I just immediately write the definition of what that means, or how does that correlate to this equation and the slope that's there. Perpendicular means I'm going to have an opposite reciprocal, right? Reciprocal, there we go. Opposite reciprocal. So that means that whatever the slope is, I'm going to flip it, right? I'm going to flip it, and I'm going to change the sign from whatever it was to, the other sign. So if it was negative, change to positive. If it's positive, change to negative. So it's opposite reciprocal. That's what I'm going to do to it. I'm going to flip it and change the sign. This one is a negative 3/4, right? This is my m. That's my slope. So the perpendicular to that slope is going to be flip it and change the sign, 4/3. Okay? So now I have a slope and I have a point, and I can put this in point-slope form again, and then manipulate it to where it becomes the slope-intercept form that I need. Okay, so here we go. Y minus what? The y value of the point is a -4, so minus a -4 is going to equal the slope. Now remember, perpendicular to this slope, we flipped it and changed the sign, is now 4/3 times x minus, and then the x value of that point is a -3. All right, again, this minus minus or minus a negative just means that we're going to have a positive. So those will just become positive. Go ahead and change them in that line there. All right, I'm going to have y plus 4 equals, and I'm going to distribute the 4/3 into the parentheses here. So 4/3 times x is 4/3 x. And 4/3 times 3, if I do that off to the side over here, 4/3 times 3, same thing as 3/1. And my 3's would just become a 1 and leaves me with 4/1, which just is a 4, right? So I'm going to have plus 4. Okay, right? 4/3 times 3/1, the 3's would cancel, leaves me with 4. All right, and then we know, just as a basic rule of thumb, we did this on some review things we did yesterday. Anytime I have the same number on both sides, I can just cancel them out, because if I subtracted 4 from this side and subtracted 4 from this side, or, you know, took the 4 and moved it over there, it's just negative. So the 4's would just go away. And when that happens, it leaves me with y equals 4/3 x. Okay, y equals 4/3 x. And that will be the answer number 16. I'm 16. Yeah, I don't know why we have 16 as the first number, but that's because it's continued, I guess, from what we did some of the problems yesterday. All right, number 17, write an equation in point slope form. Now, this is the one that we're just using to start with here. All right, so the point slope form was our, let's write it right here. Y minus y1 equals the slope times x minus x1. Okay, they give us a point, they give us a slope. But in this case, they didn't give us the slope, they just give us 2 points. But from those 2 points, we can determine the slope by using our, hold on, wait for it, slope of a line right here is y2 minus y1 over x2 minus x1. That's the definition of a slope there. We can plug in those values if we have 2 points, and we can find the slope. If you wanted to take the time, you could graph this on a grid, and you'll have grid graphing paper available when you're taking the test. You could graph that and then just count like you would here. You just count the slope from one point to the next, okay? So that's a possibility you could use as well. Use your graph paper if you need it. You could put this in the calculator, 2 points and your 2 values there for x and y's, and then you could probably create a line from that, or equation of the line, and find it that way too if you needed. But we're just going to use the form m equals y2 minus y1 all over x2 minus x1. And that, when we fill those in, will be, and we'll just make this 0.2 and this 0.1. So my y value of 0.2 will be a 5 minus a -3 over the x value of 0.2 minus the x value of 0.1, which would be a minus a -1. And so this should end up equaling 8/3. 8/3. Okay, so that's my slope. Now I have a slope, and I can pick either one of these points to put it into this slope or point slope form. So I'm just going to pick the 2 and 5. It makes it easy and nice because it's right there. So I'm going to take those 2, and I'm going to put it in the form y minus y1, which in this case we only have 1 point we're dealing with, the 2 and 5. So y minus 5 equals the slope, 8/3, times x minus 2. And that is already in my point slope form, so I don't have to do any manipulating of the equation to change the form there. Y minus 5 equals 8/3 times x minus 2. All right. The next one, number 18, we've got, it's going to go through 4, 4, and it's parallel. Okay, parallel. What does that mean? Same slope. I like hearing that. Same slope, because that just means I'm going to take that slope that's right there, that point, and I'm ready to plug in the values at this point. Okay, I can just go y minus what? The y value of the point, 4, equals the slope, -1, 6. It's the same slope as this one because they're parallel, right? So that slope times x minus 4, and we are done with that one. Easy breezy. Okay, this is in point slope form, so we don't have to change anything. We're done with 17 and 18. All right, number 19. Number 19, write an equation in standard form of the lines shown. Now, at this point, when we do these, we're going to probably end up with some fractions, and we're not going to spend too much time trying to get those undone, we'll say. But when we get standard form here, the main thing we're looking for is we're trying to get this in order of ax plus by equals c, right? So we're getting it ax plus by equals c, and then we might capitalize these here. And you'll see that that's on your chart as well, your reference materials here for the STAR testing. You're going to have this. When it asks for standard form, just look here, and it'll tell you what form you're supposed to be in, ax plus by equals c. Okay, so that's readily available. You don't have to memorize these formulas right now. Ax plus by equals c, and to put it in that form, I'm going to have to get some information from this, right? I think I could probably get a slope from this. I've got a point. I could start with these up here, the point slope form, and then rearrange it to be in this standard form, okay? So the first thing I'm going to do is try to find the slope of this line. I already have 2 points, so if I have a point and a slope, I can build the equation. Then I can rearrange it. All right, so what's the slope of this one? It's already graphed for me. I don't need to do the y2 minus y1 over x2 minus x1 when all I have to do is just count, right? Can I count this and get the slope? Sure. So I can go down 1, and then I can go over 1, 2, 3, 4. So down 1, that's my change in y, over the change in x, which is a positive 4, right? Going from left to right. So my slope is -1 over 4. And then I just need to pick one of the points. I'm gonna go with -2, -2, right? So -2, -2. I've got a point. I have a slope. I'm going to start out writing this in point slope form like the ones above, and then I'll just change it to be standard form. So I'm going to have y minus a -2 at this point. We know that's just going to be y plus 2 equals the slope -1 over 4, right? Times x minus a -2, which is just plus 2. Okay, so at this point now I can distribute the -1/4 into the parentheses. All right, so I'm still going to have y plus 2 on the left, -1/4 x, and then -1/4 times 2. That'll end up being a -2 over 4, which reduces to be a -1/2. Okay? That's just -1/4 times 2. It reduces to be a -1/2. Now, standard form says that I need the x term to be over here with the y term, and I need all my constants to be on the right. Okay? So I'm going to move the -1/4 across, which will change the sign. I'm going to move this 2 across, which will also change the sign, and I'm going to rewrite this over here, okay? I'm going to rewrite it over here. We've got a little more room. So I'm going to have a -1/4 x, right? That's my ax, plus b, y, which b is just a 1, so I'm just going to have plus y, equals, and then 2, when I bring it across, I'm going to add -2 and 2.5, and that's pretty simple. That's just going to be a -2.5. Okay? Yeah, there's fractions, but it's in the order that we need it to be in, and we could get rid of that 1/4 rather quickly. What would we do to get rid of that fraction in the leading term there if we want to just, wipe it out real fast? What would be the first thing we do? We can multiply by a 4, right? Can you just multiply by a 4 or even a -4? It doesn't matter. And then the 4's will become a 1, and that'll get rid of that fraction in the front. And it'll also help reduce that fraction that's on the other side of the equal sign. Okay, so then moving on to number 20, we're going to have the same thing. Can I find the slope? And I can just use a point that's already here. In fact, I'm probably going to pick 1, 1, because that's an easy one. And the slope's easy because I'm going up 1, 2, 3, 4. And then I'm going over 1, 2, 3. So it's up 4, changing y is a positive 4, and then I move to the right 3 in the x direction, so the change in x is 3. Changing y over changing x, 4 over 3 is my slope. All right, and then again, I'm just going to drop this right into my point slope form. Y minus 1 is going to equal 4/3 times x minus 1. And then I will distribute the 4/3 into the parentheses here, so I'll have y minus 1 equals 4/3 x minus, and then 1 times 4/3 is just 4/3. Okay, and then once again, at this point, I need the 4/3 x to be over here with my y. I need this negative 1 to be over here with the 4/3, or the negative 4/3. So when it goes across, it'll change the sign of each one. I'll rewrite this. I'm going to have a negative 4/3 x plus the y is going to equal, when I move this 1 over here, it makes it positive. And think about this. This negative 4/3 is the same thing as a negative 1 and 1/3. And then I'm adding a 1 to that. So the 1's end up canceling each other, and all I have left is this negative 1/3. So this just becomes a negative 1 over 3. Okay? And again, you'll have calculators. You could put that in the calculator. It'll give you the answer. If you wanted it in fraction or decimal form, it could do that for you as well. If you get a decimal, you do math, enter, it changes to a fraction. All right, and then, as I said before, this has a fraction leading in the front. Standard form, we're in the right order. If I needed to change that, I just multiply everything by a 3, and that'll help get rid of that fraction in the front. But for now, we'll take that right there as standard form. Okay, so that's 19 and 20. Let's look at number 21 and 22. Little review on direct variation. Okay, a little review on direct variation. Direct variation means that y, to have a direct variation, there can't be a constant. Okay, so you might make that little note down here. No constant allowed. Okay, no constant allowed. It has to be in the form of this y equals ax or y equals mx. You could see it like that, okay? But there can't be a plus c on the end. Okay, can't be plus c on the end. So does this one fit the description? What about number 21? It's okay, there's no constants. So that's a plus. We're moving in the right direction, right? There's no constants. The a or the m, whatever how you want to look at it, is in front of the y. But I can easily divide this side by 3/2 and put it on the other side, right, with the x. And all that's going to happen is I'm just going to flip this and multiply, right? I'm going to multiply by 2/3 on both sides. So that the 2's will cancel, the 3's will cancel. Leaves me with y. And so then I'll have 2/3 x. Now, is that in the same form that we need it to be? Yes. Because there's my ax or my mx, if you want to call it that. All right, and so this one's a yes. Okay, it's in the right form, right? There is no constant, right? And it fits the form. Okay, it fits the right form. What about number 22? Is there anything in here that sets off an alarm immediately? Yes, the negative 4 can't have that, so this is a no because it does not fit the form. Right? Does not fit the form of one of these two up there, right? Either ax or mx. We cannot have a c. Cannot have a c. Okay, looking at number 23 and 24, we're going to graph the equation and identify the intercepts. Find the slope of the line. Okay, so we're going to find the slope. We're going to graph it, identify the intercepts, and find the slope of the line. Well, finding the intercepts is going to be the key to graphing this real quick, in my opinion, because if I'm trying to find intercepts, I'm looking for the y-intercept. That means x is going to equal what? 0, right? X is 0 whenever we cross the y-axis. And if I'm looking for the x-intercept, what's the y value going to be? 0, right? So let's just draw a little line here. And I'm going to look for the y-intercept. So I'm going to set x equal to 0 and find out what y would be when x is 0. Oh, that's easy. That goes away. Divide both sides by 5. And so y equals 2. So when x is 0, y is 2. That is my y-intercept. Can I graph that point? Absolutely. At 0, 2, I'm going to have a point for that equation, that line there, okay? Now, what about the x-intercept? Well, the x-intercept happens when y is 0, okay? So I put a 0 in for y. And now, when y is 0, what's x going to equal? Well, that goes away. We just divide this by 2 and that by 2, and x equals 5. So now, when x is 5, y is 0, that's my x-intercept. Yeah? Can I plot that point? Absolutely. 5 and 0. And so now I can put my line going across here. And if I want to know the slope, because I've already graphed it, right? If I want to know the slope equals a change in the y value over the change in the x value. We're going to go down 1, 2, and over 1, 2, 3, 4, 5. So we go down 2, over 5. There's my slope. So I found my y-intercept, my x-intercept, and I found the slope of that line. Okay? Not too difficult. We should be pretty familiar with all this. Should be in good shape so far. All right, on this one, this is going to be very simple because this one's already in mx plus b format, right? Y equals mx plus b. What is b? What is that? That is the y-intercept. So where does this cross the y-axis? -2, right? -2. So I know I'm going to have a point right there. Okay, well, that's one of my points. What's my slope? The slope is already in there too. It's 3 over 1. So I can go up 1, 2, 3, and over 1. Up 1, 2, 3 over 1. And I can draw the line going through there like that. And it doesn't cross right at a whole value. But that's okay. I can still find the x-intercept because the x-intercept happens when y is 0. Right? When y is 0, we have the x-intercept. So what will make this equation true? How can I solve for x? Well, I'm just going to take and move this -2 across, which will make it positive. So 3x is going to equal positive 2. And x, when I divide both sides by 3, is going to equal 2/3. So at 2/3 and 0, that is my x-intercept. Right? And I already know the y-intercept was a -2. We already found that out. That's going to be at 0, -2. Okay? So there's my y-intercept right there. And the slope we already determined also was a 3. All right, so we know it crosses right there, which makes sense. That's about 2/3 of the way across the block. All right, let's look at the next problem. The next ones deal with solving linear equations using any method. These, we're not going to work both of these because we've been working these quite a bit on some of our previous reviews and tests. But this first one, I know that I would go in here, and since these are the same coefficients for x, I would just minus these two equations and solve by elimination. So I get rid of this x term. That'll make that go away. When I minus a negative y here, that'll be a plus 7y. When I minus a negative here, that'll make a positive 21. I'll divide by 7, and y is going to equal a positive 3. Okay, so that 14 is positive, but when I minus a negative 7, that means we add 7 and 14 together, which makes 21. All right, so this value we'll just take and plug into either one. Doesn't really matter. Plug into either one of those and find my x value. So I'd have my x and my y value. That would be the solution to both these. It's where these lines will cross, obviously. So that's probably how it's solved. Number 27. Number 28. I would need to divide this by -1 probably first. But divide that by -1, this whole side by -1, which means x is going to equal 6y minus 19. And then I'd probably take that and use substitution. So I used elimination on this one, but here I'd use substitution. I take that value for x and plug it in right there and solve for y, then find the value for y and come back and solve for x. Okay, so we've been doing some of these systems of equations already, so I'm not going to go through all of that right now in this particular review. All right, number 29, graph the system of linear inequalities. Okay, so we're going to graph the system of linear inequalities. We're going to treat these just like linear equations, and we are going to graph the lines, whether they be solid or dotted, and then denote which side the shading should happen. All right, so on the first one, we got y. This is just like the form y equals mx plus b, right? Y equals mx plus b. So what is the slope and what is the y-intercept of this first inequality? So slope is what? Slope is just 1, right? And then the y-intercept is just 1. So I'm going to go to 1 on the y-intercept, put a point, because that's my y-intercept, y-axis, 1 on the y-axis, that's my y-intercept. And it's just 1 over 1. So I'm going to just go to the corners of the blocks here, just up 1 over 1, up 1 over 1. It's an equal to sign. The equal to sign tells me that it can be a solid line. So I'm going to draw the solid line going through. Okay? And then it says it's greater than. So I'm going to put little arrows here showing that I'm going to go on that side of the line when I shade in just a minute. Okay? All right, so now the next one. This is my next equation. It's not in y equals mx plus b format, but I can get it there real quick. So I'm going to change this, move this across, which means I'm going to have y greater than or equal to a negative 1/3 x. It's negative 1/3 x because when I move this across, it changes the sign. And then minus 3. Okay, so now what is the slope and the y-intercept? Slope is the negative 1 over 3. The y-intercept is a negative 3. Again, just reading this in that form that we already know, that slope-intercept form. And so I'll go to negative 3. I'll put a point on the y-axis there. That's the y-intercept. And then it's negative 1 over 3. So down 1 over 3 would be a point there. Up 1 and back 3 would give me a point there. Up 1, back 3, somewhere over there. So when I draw this line coming across, this one's also solid because it's equal to as well. So I'm going to have this coming across right there. And this one's also greater than, so it's going to go in this direction and this direction. What I'm looking for is where do the arrows point to the same location or section. And this one points across here, this one points across here, right? I don't get an arrow pointing back from this line into this one, so this doesn't work. This doesn't work because none of the arrows point here. I'm pointing here, nothing pointing down. So these both point in this direction. We can shade this area here. Okay? Can shade that area because both lines have arrows pointing to that section. All right. Number 30. Number 30 will do the same thing. I'm going to get this into y equals mx plus b format. And so I'm going to have to move the 4x across, which means I'll have a negative y less than or equal to a negative 4x minus 1. Change the sign when it crosses over, right? Or we subtract 4x on both sides. I need this to be positive, though, so I'm going to divide by -1, divide by -1, divide by -1. So this will be y greater than or equal to, because this negative means I change my sign. Okay, it changes the inequality sign. All right, and then I'll have 4x plus 1, because this -1 will change the sign of those two. So now this is in the right order or form, and I can pull out my slope, and I can pull out my y-intercept. All right, well, the slope is a 4, the y-intercept is a 1, and so at 1 I will have a point on the y-axis, and then I'm going to have a slope of 4 over 1. I can't go up, but I can go backwards, so 1, 2, 3, 4, and over 1. And I can guess here it would be somewhere right in there. So I'm going to draw this line. This one's a solid line because it's equal to, less than, or greater than or equal to. All right, so I'm going to have that line, and it's going to be in this direction here, right? It's got to be bigger than that line. So anything on this side, greater than that line. All right, and then this one's an easy one. There is no x term, and the way an x term goes away is you multiply it by 0, or you have a slope of 0. And so y is less than the value -3, just means it's a horizontal line at -3. So I'll put a couple dots there, but this is also a less than but not equal to. So this is a dotted line because I cannot be equal to the value of -3. I have to be somewhere above or below it. In this case, I have to be below it. So I have to be below the line -3, below the line -3. Both of my arrows point to this section. Arrow from one line and the other point to this section, so that's the section I can shade in for the inequalities there. Okay, moving along, we're going to look at sums and differences of different polynomials, we'll say. And what it wants to know is, it wants us to find the sum and difference, and then it wants to identify the degree of the sum or difference and classify it by the number of terms. Okay, so looking at number 37, what does the plus do to all the parentheses here? What does the plus do? It doesn't do anything, right? It does nothing. So we can just basically get rid of the parentheses because plus between them doesn't really matter. And we can just start combining like terms. We have a 3x squared and a 4x squared. That's going to equal 7x squared. Those are done. We have a 6x and a -8x. We put those together, we get a -2x. And those are gone, and all of our terms have been combined. And now this is the sum of those two. What is the degree of this polynomial here? What's the degree? What we look for is the highest degree of the x, or of the variable here. In this case, is the x. And so this is a degree of 2. Right? Degree of 2. What about the terms? How many terms does this have? Well, there's only 2 terms. This term and this term, right? So we have 2 terms. So this is, because there's 2 terms, this is a binomial. Binomial, bi meaning 2, okay? So we have a degree of 2. This is a binomial. This is the sum of those polynomials or those other 2 binomials we already have. Okay? That's a pretty easy one. The next one is not too much more difficult either. This is a difference, and all we got to remember is what does the negative do to this parentheses? It just flips all the signs, exactly. So we're going to have 3 plus 7x cubed plus x to the 4th. And then we just take this negative sign and apply it to everything in here. So it'll be instead of a positive 8, it'll be a -8. It'll be a positive x and a positive 4x to the 4th. Okay, and then we can start combining like terms. Okay, we can combine like terms. So I have, the highest degree I have is a 4th, right? I have positive x to the 4th, positive 4x to the 4th. So the total, when we add those together, is going to be a 5x to the 4th. So now those are taken care of. The next degree is a cubed. I only have one of those. It's positive, so I have a positive 7x cubed. That one's taken care of. There are no x squareds. So the next will be an x, right? So I'm going to have just one of those. So I have plus x. And then I have the constants 3 and negative 8. When I put those together, I'm going to have a negative 5. All right, so that's my difference. That is my difference. And then in this case here, I'm looking for the degree. It is the highest term that I have here, highest degree term, which means it's going to be a 4. And this one has more than 3 terms. And yeah, there's names for this, but we've only gotten up to trinomials. We have monomial, binomial, trinomial, and anything after that, we're just going to call this a polynomial, okay? Because it has many terms. How many did it have? It actually had 4 terms. We'll go ahead and write that down, but we're just going to call it a polynomial, okay? So the degree of 4, and it's a polynomial. Pretty easy stuff, pretty simple here. All right, now on dividing, I'm just going to work one of these because, again, we've done some of these in the recent past lessons here. It hasn't been too long ago that we did division. So let's look at number 39, and let's work that one. We're going to have 8x squared, plus 14x. We're going to divide that by 2x plus 7, okay? So we're going to divide that by 2x plus 7. And again, one thing you got to remember when you're doing division here is you're only really working with the first terms in this case your binomials here, because that's what's going to determine your factors. All right, so what times 2 will give me the 8, and that's a 4. And what times x will give me the x squared, so that's just one more x. All right, so I'm going to have 4x. And I'm going to multiply this times everything in this dividend here, this 2x plus 7. All right, so 4x times the 2x will give me the 8x I was looking for. 4x times 7 is going to give me a positive 28x. And then I'll subtract that, just like we would normally do long division. This will go away. Those will be 0. And then subtracting 28 from 14, I'm going to have a negative 14x. Well, when we divide until this is the answer is 1 degree less, right? So we have to be 1 degree less than this, right? So, or that the resulting answer is 1 degree less. So I've got to multiply this times something to get a negative 14, and that's just going to be a negative 7. Okay, so I have 4x minus 7. Negative 7 times this is going to be my negative 14x. I don't have another term here, but I can bring down a 0. And then negative 7 times 7 is going to be a negative 49. Okay. Now, these two will go away, the negative 14s, because I'm subtracting. That negative 14 makes it positive, so these will go away. I'm subtracting a negative 49 from 0, so it's just a positive 49. Right? That's all I can do, right? It's a positive 49. Now, this is going to be my remainder. And remember, when we have remainders, we just have to put them over this dividend here, 2x plus 7. So my resulting answer is going to be 4x minus 7 plus 49 over 2x plus 7. Okay? So that should be my answer on number 39. Number 40, you'll work, very similarly, so I'm not going to go through that one. Again, we've been doing some of these, so we'll scratch that one. Find the product. This one also, we've done multiple examples of this very recently, so I'll just kind of run through the first one to make sure you remember that all we're really doing is just we're distributing the c times the c times the negative 3. Don't forget to circle the sign whenever you are multiplying there. And then a negative 5 times the c and negative 5 times the negative 3. So we will have a c squared minus 3c. And then when we get to this part here, we have a negative 5c plus 15. I'll be able to combine these middle terms, right? Should be able to combine middle terms every time. So c squared minus 8c plus 15 should be my product. Okay, so that's, using distribution, the FOIL method. You'll hear that too. We've talked about that. We've also talked about the grid or the table option as well. So you could put your binomial on the side here, c and -5. On this top side, c and -3. You'd end up with the same terms that we had here. C times c is a c squared. C times a -3 is a -3c. -5 times c is a -5c. And then -5 times -3 is a +15. And again, you should be able to add those middle terms together. And you have the same, answer there. C squared minus 8c plus 15. So whichever method works best for you, if you want to distribute or if you want to use the table method as well, you can do that. All right, again, I'm not going to work all of these because they're all the same thing. We're just going to distribute all those and combine like terms. So that's 41, 2, and 3. Let's look at 44. Factor the polynomial completely. We have 4 terms, and if we ever have 4 terms, we're supposed to group it and see if we can do some factoring by grouping, right? And in the first group, can I factor something out that's common? And I should be able to in this case, and that is a b squared, okay? So b squared. So b squared I can take out of the first term, and I'll be left with a b. I'll also be able to take a b squared out of that second term, leaves me a 3. And then I have b minus 3 still on the second term there. Now, among these two terms, I can still factor out a common term, and that is that b minus 3. All right? So, we can factor a b minus 3 out. This one will be, only thing left there is going to be a b squared. And then, if I take a b minus 3, divide it by itself, what's left is just a 1. So this would be factored completely, b minus 3 times b squared plus 1. And we did that factoring by grouping. All right, if I'm factoring number 46, again, I'm not going to go through all these in great detail, but I can do this one pretty fast if you want to. I would use the X method on this one. Would probably be easy enough. Remember that I'm going to put the B term placeholder in the bottom, and then remember the top is A times C, so it's 2 times 21, which will be 42. We look at the factors of 42 to find out what adds to be 17. Turns out that 3 and 14 are factors of 42. And so we can do that. But we know that this also has to be negative. So then our terms or our factors are going to be x minus 3. But because a is not a 1, we have to put that 3 over 2. All right. And then we'll have x minus 14 over a, which is 2. All right. And so then we can simplify this. This will become a 7. This is as simple as it's going to get, fraction form here. So we can get rid of the fraction by just pulling the 2 to the front. So my final answer here will be 2x minus 3 times x minus 7. And that is my factored form on number 46. Okay. For any of these problems that we're skipping or kind of running through rather quickly, we'll have the video posted online, obviously, but then also we're going to post a complete key for you guys so you know exactly what all the answers are. Again, 49 through 51, I'm not going to do all of these because we've just went through this section here. The first one I'll do just rather quickly again. I could just do this by square roots. If I divide by -3, divide by -3, I'll end up with x squared equals a positive 18. And at this point, I'm just going to take the square root of both sides. And so x is going to equal, just leaving in radical form here, plus or minus the square root of 18. If I did it on the calculator, I could get a decimal form if I needed to, and rounding to whatever I needed to as far as if it was to the 10th or the 100th or whatever. All right, so the last couple here, we're going to skip over, well, we could do 50 real fast. This one I could just, if I'm getting used to factoring pretty quick, I know that I've got to multiply to be 7, add to be negative 8. There's only 2 factors for 7, so it's going to have to be a 1 and a 7, right? They have to multiply to be a 7, but add to be negative 8, so they both have to be negatives, right? So they multiply, they'll be a positive. 2 negatives make a positive, but 2 negatives make that negative 8. All right, so this is just doing this X method we did on number 46, but, you know, in our heads. And then we set both these equal to 0, so we know that X is going to have to be a 1 in this case, or X has to be a 7 in that case. So those are my 2 possible answers there. And then 51, I'd probably use quadratic formula, which is something we just finished going over as well. So I'll probably use quadratic formula number 51 since it has this negative, 3 for the A term and so on and so forth. All right. The last 2 we're going to do on the calculator, so make sure you got your calculators on and ready. It says graph the function. So that's going to be pretty easy. I'm just going to put in y equals, I'm going to put 3x squared minus 1. And then I'm just going to go to my table, not my graph. I'm going to go second table. And I'm going to look at some values that I can just plot some points here on the graph. Negative 1, I can put a 2. So at negative 1, I can put 2. At 0, I can put a negative 1. And at 1, I can put another 2. And really, that's enough. The other ones are going to be 11. They're going to be off my page here. So I can graph this, pretty easily. I know this is a quadratic. So I'm going to come down here and then go back up this way. And so that's my graph. I put 3 points on there and drew my graph. All right, so on number 53, again, I'm just going to go to y equals. I'm going to clear that one out and put this one in. Anytime I'm putting a fraction in, if you can do it in decimal form, that's great. That'll be easier. If you're going to put it in fraction form, I'd suggest just putting in parentheses. And then I'm going to have x plus 4, close it, and I'm going to square that. Okay. So now I'm just going to go to my table and find some values to plug in so I can plot some points. If I went to a negative 6, I'm going to have a positive 2. If I go to 5, negative 5, I would go to 0.5. If I go to 0, okay, negative 4 and 0, and then it looks like it goes back up. So at a negative 1 or negative 2, I'm going to go to 2, and that's plenty of points. I'm going to be able to plot this or graph this pretty easily now. This is another parabola, opening upwards, and so I'm going to have a graph that looks like this right here. Okay. All right, so that is the graphs of those 2 on 52 and 53. Again, we'll have a complete key on Google Classroom. So if you're watching the video, you can go back to Google Classroom and click the links there if you're in our class, and you'll see the complete key. Hopefully this has helped you guys, and you should do very well on your practice STAR test that we will start taking in class tomorrow. All right, have a great day.